All right, let's summarize our properties of chords here in these notes. These are notes number 154. This is Monday. And the date is, what is the date today? It's May 4th. Hope everybody's doing good. And here's what we got. We got the properties of chords. This is 10.3 in your book. If you ever want to look it up, you could go to the book and look. Our objective is I will use properties of chords. So remember what a chord is. These are a couple examples of chords. Right here, there's a chord. It just has endpoints that are on a circle. And same here, this is a chord also. So let's just look at some specific properties of chords. The first one is about congruent chords. So let's just suppose I'm given here that these chords are congruent. So let's just mark this, and I would use black for the given information. So I'm just going to say that's congruent to that. That's given information, and that's my congruent chords. What can I tell if the chords are congruent? Well, one thing I can tell if the chords are congruent is that they're the same distance from the center. So I'm just going to draw in a distance here. That's that. Now, it would be the distance if there's a right angle there. Because if you want to measure the distance from a point to a line, you got to go straight at it at a right angle. Now, that distance would be the same as the distance over here. Okay, and let's just write that down. Our congruent chords, if and only if they're the same distance from the center. They are the same distance from the center. Another thing we can tell if we have congruent chords is that the arcs that they make, these two arcs are congruent. So let me mark those arcs. Those arcs are congruent. And so my rule is they form congruent arcs. So there's basically two things I can say about that. Okay, let's look at the next property, which is a radius is perpendicular to a chord. So let's go ahead and look at a radius here. We have a radius that's perpendicular to a chord. There's a radius, and I'm going to make it perpendicular to a chord. So let's just draw a chord across here. And we're given that that's perpendicular. What can we tell from that? Well, we can tell that the situation here has a little bit more information than what's given. This radius goes to the center, must bisect that chord. So it's just going to pass through the center. And we saw that before. So this is it. A radius is perpendicular to a chord if and only if it bisects it. I'm going to write the radius bisects. And remember, bisects means passes through the midpoint. So let me just say bisects. That means okay, let's look at our next thing is we're going to just do some examples here. How would we use those properties in these examples? So number 3, find the value of x. Well, I notice x is part of a chord. 11 represents the distance from here to here. So this is 11. And this chord is perpendicular to a radius. So we know that this part over here is the same. So x equals 11. Okay, in this part over here, we could notice the symmetries as well. So I have my radius is perpendicular to a chord, so I know that it bisects this chord. And I also know that there's symmetry here. So this arc right here is congruent to that arc, so I know that x, the degree measure of that arc, must be 65 degrees. And over here, I'm going to use the same property, but now I'm going to write an equation. I've got the, well, actually there's something missing here. I'm going to need to know that given that QS is a diameter, that would be given, that point. Or just the statement up here. But if I know that, then that must be congruent to that, and I could write an equation. Knowing this, I can solve the equation. Let's see, I've got x's on both sides. Let's subtract 7 of them from both sides to get the x's on one side, and I chose that one because it's the smaller x, and it's going to leave my x term positive. So that's 2x minus 3 equals, and the 7x's cancel, and I just have equals 5. Then we could add 3 to both sides to cancel the minus 3 out on this side and get the x by itself. 2x equals 8. Divide by 2, and we get x equals 4. Okay, let's take a look at the next question. It just says, determine whether the segment AB is a diameter of each circle. Explain your reasoning. So in this first case, we're trying to determine if AB is a diameter. And in other words, does it pass through the center of the circle? Well, let's see how we would conclude that. Well, first of all, we have to notice that this segment right here is congruent to the other segment that also says 17. So I'm going to see if I could draw that in here. I know I can conclude that that is congruent to this. So therefore, AB bisects the chord so that AB, it's actually a perpendicular bisector. So AB is a diameter. Okay, for B, we're trying to determine whether this is a diameter. Could this possibly be a diameter? Well, I'm going to look at this, and I have to go, well, that's definitely not a right angle. In fact, that's 103 degrees. The one on the other side would be like 77 degrees. That's not a right angle. So it does bisect it. These are congruent, but now I say, well, that doesn't meet at a right angle. So the center of my circle is going to be somewhere on this side. Like there would be a center that it's on the perpendicular bisector, which is more like this. So if I drew that in, that would be a diameter because that one is perpendicular to the chord. So this would be my diameter, and and this is not a diameter. AB is not a diameter since it is not perpendicular to MN. Okay, so there's that. Let's take a look at a couple of other problems that involve these kinds of properties. Find the value of x in the diagram. So if you're looking at x in this diagram, that is segment AB. And I might notice that this 3 and that 3 are the same. So these are the same distance from the center. So first I'm just going to say that AB is congruent to CD of the circle. And I'm just going to give the name of the circle. You should practice that. The name of the circle is circle C. Okay, A, B, and C, D are congruent because they are the same distance to the center of the circle C. So that's one of our properties, and so we know that they're congruent. So therefore, we know that the length AB equals the length CD, and I can plug those in. That is 2x. So part B asks me to find the measure of BC and AD. So let's first of all look where those are. BC is over here. That's this arc, BC. And AD is over here, this arc. Okay, so that's that one. This is a little bit more of challenging. Here's how we can go about that. First of all, let's notice that AB and CD are congruent chords. So therefore, this arc here must be congruent to this arc. Let's just use 2 marks. So I know that this is 100 degrees. Now I'm also given that this is 120 degrees. That's going to help us out because we're going to need that because I don't really know the position of these. With those both being 100 degrees, I do know that these are going to take up the rest of the circle. So I could figure out what that is. But first of all, I'm just going to think about it this way. Let's just continue these chords, these over here. And since I know that that this is a radius that's perpendicular to the chord, that means that these are congruent and that means that these are congruent. So these two arcs are congruent. That means this is a 50-degree arc, and these two arcs are congruent and they're the same as those over there. So that's also 50 degrees. So I can see that these are both 50-degree arcs. That's 50. And let's just put a variable here to represent the arc BC. I'm just going to say that, suppose that's y. Now I find this is probably the easiest way to do it, but we're going to look at maybe a different way. But that would be a way to find this. I know that this is a central angle. So this angle, angle C, is going to equal the sum of these. So the measure of angle C is going to equal 50 degrees plus y plus 50 degrees over here. So that would be the angle. Oh yeah, I know that angle C is 120 degrees. So 120 degrees equals 50 degrees plus y plus 50 more degrees. So I could just solve for y here. I'm just going to add those together. 120 equals 100 plus y. And then we can just subtract the 100 from both sides. And I get this one. 20 equals y. So y equals 20 degrees. So I found one of my answers here. It's the measure of arc BC. So I know the measure of arc BC equals 20 degrees. All right, now we're going to find out this other one, and we could probably do the same thing, but I might just go and just complete the whole circle here. So I know the whole circle is 360 degrees, so I'm just going to go 360 degrees, plus these two arcs, this one here and that one here, which is 200 degrees minus 200 degrees. And that's just 160 degrees, so I just do that. And then I'm going to also subtract off y over here, so subtract off another 20 degrees, and I get 140 degrees. And that happens to be my other arc, the measure of arc AD is equal to 140 degrees. Now I could check that out just by adding all the arcs together. Let's just do that. We have 100 plus 20 plus another 100 plus 140 for the last one we found, and we should get 360. And we do. So this is our check.